My name is Luke Dubois. I teach at Polytechnic here in the Brooklyn Experimental Media Center with Carl. I'd like to thank Carl and Sharon for inviting me to share some thoughts with you. It's going to be kind of a two-part talk. The first thing I'm going to do is sort of briefly talk about some of the work I've been doing and its relationship to, or relationship not to, Xenakis. And then I'm going to show a little demo, kind of riffing off of Carl's talk before lunch. He gave me a homework assignment, which I'd like to share with you, with some software. Yeah, exactly. So he's the boss, so I obeyed. And this fall, last fall, I was honored to be invited to give a series of artist talks at the Guggenheim Museum in relationship to a big retrospective they did of Kandinsky. And in doing so, I did a lot of research and reading and all this stuff, and I'll get to why this has to do with Xenakis in a second. The provocation at the beginning of Concerning the Spiritual in Art, Kandinsky's monograph from 1911, is that every work of art is a child of its age. All right. He also goes on to say, talking about his relationship to different arts practices in his time, that the arts are encroaching one upon another, and from a proper use of this encroachment will rise the art that is truly monumental. Every man who steeps himself in the spiritual possibilities of his art is a valuable helper in the building of the spiritual pyramid, which will someday reach to heaven. Kandinsky was not a cynic. I am. But I think this is an interesting conceptual thing to maybe start with talking about how I stumbled across thinking about Xenakis and all this kind of thing. A useful and kind of not particularly pleasant summation of that notion that I just read to you is the idea that genre creates ghetto. So that's one way of saying it. The idea that classifying oneself solely as a composer or solely as an architect or solely as a sculptor in a way puts you in a box that is useful if you're shopping at the now long gone Tower Records, but is not necessarily amenable to a lot of discussions that people should be having. And so Xenakis definitely understood this. To paraphrase, or to put it in the words of the recently late J.D. Salinger, Xenakis was not a phony. He had a very, very broad, very diverse arts practice. He was fully professionally competent and excelled in all of the media in which he worked, and he understood it as a practical continuum and not as a series of interesting little boxes that he liked to work in that didn't really relate. And so that's something that in my work I strive for. I'm not sure I'm as successful at it as he would have been, but I'm going to show you a couple things that I'm kicking around on my laptop. So when I was in graduate school, I studied composition at Columbia University. I started working with something that Xenakis knew quite a lot about, which is the mapping problem. This is something that Xenakis dealt with. That's something that many of his colleagues dealt with. That's something that many of my colleagues dealt with. That's something that many of my students deal with all the time, which is basically if you have a set of information and you're trying to realize it in some medium, what do you do? So I've got a couple little examples of that. When I was working at Columbia, a big chunk of my graduate research was developing a package of software that ran alongside Max MSP called Jitter. In Jitter, to most people, is sort of a VJ component or a live video and graphics component to this software package. And my job was to try to sort of augment that with the idea that it's really just a very media neutral way of expressing information, and so you can do all these kind of things that aren't quite right. So for example, if I talk into my computer and say, my dog has fleas, testing 1, 2, 3, right? This is a sort of standard issue sonogram of that phrase. And you would think it would be playing, but it's not. There it is. And so the idea is that by looking at this thing, I can get a plot of the sound. Right? But what it lets you do, which is kind of nice, I don't know why this is here, but it is. So by looking at this, you can see that, I've sort of turned an image into sound. That's no big deal. You can do some things with that conceit that you're not really supposed to do to sound, and that's kind of fun. So I started working with a sort of very tricked out phase vocoder, if you know what that is. It's basically a way to manipulate time and pitch independent of one another when working with sound. And unlike most of the work that we've been looking at, which deals with sort of form and math and all this stuff, my particular interest in mapping is related to culture and language. And so, but math and sound get involved in it along the way. This is a piece I did in 2005 called Billboard, where I decided to take every single #1 song on the Billboard Hot 100 and speed it up so that it lasts for 1 second for every week it's a #1. This allows you to hear the entire history of American popular music in about 37 minutes as a sequence of time-lapse phonographic averages of the harmony of the piece. Does that make sense to you? Has some really interesting little characteristics. All of 1978 is in the key of F. Right? Andy Gibb can only sing one note. But it also gives you a really interesting idea of cultural canonicity, right? This is a list. And this is a list that we ascribe cultural value to. And if you listen to pop radio, you have part of it memorized, right? I lost my virginity right there, right? So you have this kind of idea of a data set. You want to make something out of it that speaks to the data set. How do you work with that? So that's sort of the arts practice I'm coming from. I'll just show you a couple other little guys. During the time that I was working on these pieces, I was grappling with the idea that I was performing with a laptop computer, and a laptop computer really has no business making sound. It's utterly lacking in body. It's a piece of plastic. And it poses a couple problems in live performance. Two of them that I can think of offhand. One is what I call the transparency opacity problem, right? It's a very transparent technology in the sense that everyone in your audience owns one and thinks they know how it works. But it's a very opaque technology because I could be sitting up here right now checking my email while I'm performing, allegedly. Another way of looking at it is to look at it in an aesthetic domain, right? You can think of, I don't know, jouissance and plaisir, right? If you're unfamiliar with those terms. Plaisir is a really nice car. Jouissance is having sex in the back of a really nice car, all right? A violin is in the jouissance category. A laptop is in the plaisir category. It's a toaster oven. It's a thing that helps you do your taxes. How do you deal with that as a performer? So I started making these synesthetic objects. I started designing software that would, I hope, serve as an amplifier for the music that was coming out of my laptop in an attempt to reinvigorate it as a body. This little piece, which I wrote for a string quartet called Ethel in 2005, is analyzing my voice, attempting to track its rhythm, and creating these origami folds based on the timbre of the input sound. All right. I don't necessarily believe that this solves a problem per se that I was sort of referring to, but it's an interesting way to force the audience to engage in perhaps the underlying process of what might be going on, which is one of the challenges when you're working in especially algorithmic electroacoustic music. So one summary of that would be something like this. This is a piece that I wrote for guitar called Growing Pains. And this is an algorithmic reactive piece. The guitarist is playing into the computer is listening, and the notes that the guitarist is playing are moving that little puck on the screen. If you're into this sort of thing, that puck is called a turtle. If the guitarist plays the piece perfectly correctly, you get a plant. If the guitarist makes a mistake, you get a slightly different plant. In the business, we call this a mutation. It's no big deal. It happens all the time, right? But in order to really understand the underlying compositional praxis behind the music, it's really helpful to visualize it. All right? So a couple other really quickie things on that. A couple other pieces of mine, just to show you the kind of information that I try to show. This is a piece that was commissioned by the Democratic National Convention in 2008. It's called Hindsight is Always 2020. It's not a sound piece, it's a sculpture. And what I did was I took all the State of the Union addresses of all the presidents and turned them into eye charts. So you can test your vision, which is how we test people in history. We say they had vision or not, right? So this is George Washington's eye chart. Word he uses the most is gentleman. Our last president's was terror, right? A couple other good ones. Richard Nixon, interestingly, was truly. Ronald Reagan was deficits, right? What this piece does is it allows you to get a sense of the rhetorical zeitgeist of different presidential sort of eras, right? So that's kind of an interesting thing. What you end up with, let me open that up one more time and actually fit it on the screen real quick. There we go. The way it shows itself is as 43 large light boxes, which about a week ago were completely destroyed by a tornado in Arizona. It's very exciting. This is how they looked outside the Democratic National Convention. This is how they looked at the National Constitution Center in Philadelphia during last year's election. Right? So these sort of freestanding sculptures. Right? So that's a mapping thing. And while it might seem sort of fairly obvious that you would array text that way, we're sort of used to things like tag clouds and whatever. Having an underlying metaphor, that of the eye chart, is something that sort of helps bind it together. A couple other quick little pieces, and then I'll move on to the project. I was commissioned last year by Turbulence, which is the sort of online wing of New American Radio and Performing Arts, to do a piece based on the information of the Iraq War. And I made a piece called Hard Data. And Hard Data is actually very much inspired by Xenakis in a couple ways. One, in the sense that it's a multimedia work. It has a sort of ability to have a visual agency as well as a sonic agency as well as a metaphorical agency. But the other idea is that it's based on statistics. But it's not based on stochastic statistics. It's actually based on a real data set from a real war in which real people died. So this is a visualization and sonification of the casualty stream of the war in Iraq. This is the online version. So the idea is that you essentially accelerate the war to last for 1 second for every day. You create notes based on military civilian casualties. The notes are drawn in a little bit of a postmodern way from Maltanin, which is the current Iraqi national anthem. And it has an arc to it that quite literally, oh good, flash, quite literally follows the trajectory of the war. So you go through the insurgency to the surge, and it has a narrative arc. I found a lot of inspiration in the music of Xenakis for this piece simply because as a composer, he had a very multi-layered, multi-leveled aspect to his compositional praxis, whereby you had very different kind of formal hierarchies existing at different levels of the piece, somewhat maybe akin to the military experience of the distinction between strategy and tactics. You may have incredibly clean lines going on as armies move across the battlefield, and then at the event level, all is chaos. So that was sort of the idea. It was realized as a string quartet last summer. I won't really bother showing you the score or playing you the music. It's all on my website. But for the string quartet, I made it in 6 movements based on the casualties of civilian men, children, women, the soldiers, the refugee stream out of Iraq, and those who had gone missing, taken from public sources. So, on to something a little bit more fun, maybe. We've all seen these sketches about 50 times now, but I'm going to put them up here again. Carl challenged me with the task of realizing his Eureka moment at La Tourette of sort of looking at a building and seeing how that building might make sound as a sequencer. I am not so much a sequencer kind of guy, but that's maybe a good thing. And so what I did instead was looked at these buildings. I looked at La Tourette, and I also looked at Chandigarh, and I also made a couple simple ones, and sort of deconstructed them into something I do know a little bit about, which is grammar models. And so the idea is if you look at the facade of the Chandigarh building, you can think of it as being in 4 tiers. These letters are actually in the plans, more or less. Each of those tiers you could think of as being made up of windows of different lengths in centimeters, right? But what I did instead was I substituted them as letters just for the purposes of attempting to demediatize the structure of the piece. So if you think about it, anywhere there's an A, what you're looking at is you're looking at a series of panes of these lengths, and this is the key over here in centimeters, okay? Does that sort of make sense? It's not so bad. We'll get to this bit in a minute. All right, so, whoops, so you can sort of, bop through it, all right? So we can load up Chandigarh and say, go, right? And it'll, play through it, the mapping being that of taking the lengths of the windows and turning them into time, right? So this isn't particularly sonically interesting, but it's just a rhythm, okay? All right, you can decide to look at just one of the sort of microstructures by itself. You can look at the different rows of the building individually. You can just riff off of one of those little cells if you want and see how it sounds, right? So this is, whatever this is, 33, right? Not that exciting, okay? But you're trying to figure out like maybe a better way of turning it into sound. Might be something like this. If I turn it into a polyphonic sequencer, okay, let's do the first one. And let's do Chandigarh. Chandigarh is a little bit easier because it's just got a sort of simpler polyphony. So this is just, what the heck is this? This is a sine wave. Well done. Okay, not that exciting. The pitch material is, again, being based on the length, okay, as is the rhythm. I can set an envelope and whatever. But what I thought might be interesting would be to show it while you play it. So this is a sort of first step of that. Show it. Let's keep this going. Okay, go. Right, so there's some windows unfolding for you. I don't know if that's the best way to look at this, though. So, can I move it? Oh, yeah, hey, wow, it's 3D. But that gives you sort of a sense of the structure. The red lines are when the cells repeat, so when an A or a B or a C kind of repeats, you get a sense of the underlying structure, right? But I decided to try 2 things. One a sonic decision and one a visual decision. For the sonic decision, I decided to change the synthesis algorithm. This is where we get really nerdy. Change the synthesis algorithm so that rather than simply working with sine waves, I constructed a physical model, basically a modal bar. And so what I'm doing is I'm taking the lengths, the sort of larger macro lengths of the structure, and treating those lengths as harmonics of a node, okay? So that we're imagining this is basically a big marimba. So it sounds like this. Not so bad. Let's do La Tourette. Let's start over. All right? And then, in terms of how you look at it, I figure, let's get this all going here. Come on, kids, you can do it. Oh, I have to load the file again. This is where I go into demo mode, nothing works. There we go. Get something like this. These are the top 2 structures, okay, and how they relate with the chasing sequencer. Okay. This is all being rendered, in real time with a max patch, which I will upload and give to you all so you guys can play with it. shows some interesting things about what it would be like to actually chase down this building and make sound off of every window and use it as an event stream. It also makes for an interesting way of looking at a sequence as a physical structure, maybe. And I'll show you one last sort of trick, because I don't want to run over Sharon's watch here. But let's say, for a minute, I had something really simple. Let's do a simple one. All right. Okay. So this is literally a really simple monotonous pattern. So I'm going to mute the keyboard so that you don't go crazy. The idea is we have two floors. The macro structure of those two floors is basically a structure called A, followed by a structure called B. On the bottom floor, a structure called B, followed by a structure called A. Those themselves are made up of a couple of windows, all right, an A window and a B window and a C window and a D window. These are their lengths. Pretty exciting. So if you sort of look at it again, it might actually make sense out of patterns. But now the trick is, what I really want to do is I want to make it so that the building changes over time. And so what I'm going to do is I'm going to put in a substitution macro. I'm going to say, you know what? Every time I run this thing, when you see an A, replicate it with a B then an A, so it actually gets denser. Right? And then every time you see a B, turn it into an A. There's a guy named Noam Chomsky who had a few things to say about this system. Okay, and so if I open up the evolve patch, oh god, that's ugly, and load in some substitutions, and this is our set, hit some buttons. Boop, 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 boop. Okay, now I've made all sorts of stuff, and now what happens is I end up with a much more complex system, okay? The way they're interlocking. Because of this database amplification of substituting them. If I take one that I've got kicking around, that I just made up at lunch, I will, where is that? Luke, here we go. This is another very, very simple one. I think it has 7 floors, though. I have no idea why I decided to do that. But yeah, it has 7 floors. It has 4 possible rhythms. Again, very, very simple. Just the idea of 50 centimeters, 75 centimeters, 25 centimeters, and 100 centimeters. And you kind of treat each floor as being made up of little groups. All right. By the time you start going, let's see, is this actually playing? Of course not. That would be too easy. All right, now I got to do my little like load the thing, hit the reset button again, and let's make this look a little like hipper. There we go. Let's turn on the Smiro vision. All right, is this actually playing? Yeah, there we go. All right, so okay. So we got 7 floors of this fairly melodic rhythm. If I start evolving it, though, this one I can evolve on 2 levels. I can evolve on the macro level, sort of how these bigger structures unfold. And then I can also evaluate it on the micro level by changing the actual letter substitutions. So I'm going to do that a bunch of times. It's like the coolest sound it makes. Hit that button. And now I've actually got a fairly complex pattern that will take a very long time to repeat. And one of the interesting side effects of this type of database amplification, this is really kind of a Lindenmayer system, is that it will progress toward infinity because these strings of symbols grow. I like working with letters instead of numbers simply because it sort of clears my head a little bit, but it also allows you to kind of look at the system that you're working in less as just sort of a simple math problem and more as a sort of conceptual framework for actually manipulating linguistic structures. I think of one of the reasons why Xenakis' music is so compelling and stands up to repeated critical listening is simply because of the formal hierarchies he's using are of sufficient complexity that they actually have a language all their own. They're not by any means random, if that's a good way of saying that. So I will not take up any more of your time except to show you one can I play like 2 seconds or something? Okay. It's to show you a sort of sonic, an actual rendered version of what this graph is sort of doing that I sort of did as an early mock-up before I could visualize it or anything like that. And so this is a little sound piece. Right. Again, treating the La Tourette plans both as a score but also as a synthesis model, if you will. And what I do over the course of this piece, I won't bore you with it, it's 8 minutes long, but is I start cheating the numbers a little bit by forcing them to conform to a regular metric grid. And so as a result, what starts out sounding, if not stochastic, then certainly experiential or gestural, eventually turns into something that you might actually recognize as a beat. Still based on the same structure, the same math. Carl thinks this is pretty. Yeah. Anyway, there you go. Thanks for your time. All right. Oh, right. That's the last bit, sorry. This is all that software and stuff that I just made in case anybody wants to play with it, is until we move it over to the BXMC, is just going to be here. Easy enough, right? So that's my website, and it's just x for Xenakis.zip. I'm just going to put that up right now. Okay, thanks.